Ever wondered what causes a migraine to persist or worsen over time? Well, let's dive into the intriguing world of migraine chronification and its intimate relationship with inflammation. Migraine chronification is a progressive process in which the frequency and severity of migraine attacks increase over time. Now, you might be wondering, what's inflammation got to do with it? Here's the connection. The activation of the trigeminal system, an essential component of our nervous system, is linked to the onset of migraines. This system gets activated by various factors, including inflammatory responses. One of the most widely used treatments for acute headache episodes are non-steroidal anti-inflammatory drugs, also known as NSAIDs. Their widespread use hints towards the involvement of certain neuroimmune responses in the development of migraines. In addition to NSAIDs, steroid injections in the region of the greater occipital nerve are often employed as a preventive measure against chronic migraines. These methods aim to control the inflammation, thereby managing the migraine symptoms. The plot thickens with the involvement of a neuropeptide called CGRP, or calcitonin gene-related peptide. In animals, sustained CGRP release may induce peripheral sensitization, which is likely due to the release of inflammatory mediators like bradykinin and prostaglandins. During a migraine attack that can last for up to 72 hours, the levels of CGRP are found to be increased. This leads to continuous activation of C fibers, which store CGRP, and of AD fibers, which contain CGRP receptors. This continuous activation may lead to the production and release of inflammatory cytokines, contributing to the intensification of the migraine. In conclusion, the intricate dance between inflammation and the nervous system plays a significant role in the progression of a migraine attack. From the activation of the trigeminal system to the release of CGRP and the role of inflammation, each step contributes to the chronification of migraines. So the inflammation and the subsequent responses play a significant role in the progression of a migraine attack. Did you know that your body's own defense mechanisms might be contributing to your migraine? Let's delve deeper into the science of it. The activation of the trigeminal system, a key player in our pain response, releases inflammatory cytokines. These are small proteins that act like messengers among cells. When these cytokines are produced and released, they can potentially affect pain neurons, signaling the sensation of pain to our brain. Now let's consider the role of the calcitonin gene-related peptide, or CGRP, a neuropeptide that is found increased during a migraine attack. Interestingly, there are CGRP receptors on ganglion cells, which are clusters of nerve cell bodies. The continuous activation of certain nerve fibers storing CGRP and containing its receptors may lead to the production and release of these inflammatory cytokines, not only in the peripheral system, but also in the neuronal cell bodies located in the trigeminal ganglion. But the story doesn't end there. Other cells like neurons, microglia, astrocytes, macrophages, and T cells can also release cytokines and chemokines. These substances can activate pain neurons directly, depending on the expression of their receptors on non-neuronal cells. Key players in the inflammatory pathway include major cytokines such as tumor necrosis factor, or TNF-alpha, interleukin-1 beta, or IL-1B, and interleukin-6, or IL-6. TNF-alpha, for instance, has been suggested to be involved in the initiation and progression of a migraine attack. This is a potential pain mediator in neurovascular inflammatory conditions. Moreover, studies have observed changes in plasma, serum, or urine levels of TNF-alpha in migraine patients during attacks and even during attack-free intervals. This suggests that there's an ongoing neuroinflammatory process even in the absence of an active migraine attack. Therefore, our body's own defense and inflammatory response could be a key player in migraine chronification, making it a complex and multifaceted condition.